So, good morning, students. Me.P.Kanagalakshmi, I am assistant professor from CSE department in PSN College of Engineering and Technology. So, today we are going to discuss about introduction to compiler design. Okay. So, before that, what is a compiler? So, compiler is a language. It's a language translator that takes an input as a high-level language program and then produce a low-level equivalent low-level language program. For example, if a compiler, if we take if a high-level language is a C++ language means, so that language is translated into an executable code running on a processor. That process takes place in the compiler. Okay, so compiler is nothing but is a language translator. It takes an input as a high-level language program and then produce an equivalent low-level language program. Okay, so before that, next to move on to the what are the phases of a compilation. In the process of translation, a compiler goes through several phases. So first phase is a lexical analysis, the next one is a syntax analysis, then third one is a semantic analysis, next optimization, and the last one is a code generation. In that, lexical analysis is also known as a scanning. Then syntax analysis also known as a parsing. Likewise, they are categorized the phases of a compilation or the phases of a compiler. Okay. Next, to move on to the what are the here your diagram shows the phases of a compiler. So first you have to give the input as a source program. So that source program is taken into account into the lexical analyzer and then syntax analyzer and then semantic analyzer and then intermediate code generator. Next one code optimizer and then code generation. So from that code generation you have to get the output as a target program. Okay, so you have to give the input as a source program, but finally you have to produce the output as a target program or the object program. Likewise, we are saying that is output. Okay, so each phase here they have 6 phases. Each phase they can transform the source program from one representation to the another representation. Okay, so in the all the phases they can communicate with the error handler. So what's the need of error handler means if any of the phases have sometimes have some arises some errors. So for this you have to error recovery. For the error recovery mechanism you have to introduce the error handler mechanism. Okay, so in each and every phases they linked with the error handler, as well as they had also a symbol table also. So each and every phases they can communicate with the symbol table. So in that symbol table they have information about the each and every phases. So what are the identifiers here, what are the keywords, okay, what are the value of a constant. Okay, but likewise they are given the information in the symbol table. If any of the phases they need information to undergoes another process means you have to get the information from the symbol table. So this is the uses of the symbol table here. Okay, so here the diagram shows the phases of a compiler, this architecture and phases of a compiler. Okay, so first phase is a scanner. So scanner or maybe lexical analyzer. The second phase is a syntax analyzer or maybe parser. Next one is a semantic analyzer, then intermediate code generator, and then optimizer, then code generator. Okay, so from the lexical analyzer get the input. Okay, the input is like a stream of characters. From the lexical analyzer, we have to produce the output as a stream of tokens. That stream of tokens is given an input to the parser. So from the parser, we have to produce the output as a parse tree. So that parse tree is given as an input to the semantic analyzer, and then from the semantic analyzer, we have to produce the output as a abstract syntax tree. Okay, so this is input to the next phase, that is a intermediate code generator. So from the intermediate code generator, we have to produce the output as an intermediate representation. From the intermediate representation is given as an input to the optimizer. Then from the optimizer, so this is optimized intermediate representation. So this is optimized intermediate representation. Again, give an input as a code generator. From the code generator, we have to produce as a target code. Okay. So already we are saying Already I said that. So each and every phases they communicate with the error handler as well as the symbol table. So okay, so what's the need of error handler means if any of the phases they have they sometimes they have some arises some errors. Okay, so how to resolve that errors? So you have to resolve that errors through the error handler mechanism. Okay, so that we have to each and every phase they communicate with the error handler. Next, this is simple table manager. Okay, so each and every phases they communicate with the simple table manager. Okay, so they have additional information about so each and every phases. So that information stored in the simple table manager. Okay, so if any of the phases they get the information from the symbol table manager, not from any of the phases. They cannot communicate with any other phases. They can communicate with only with the symbol table manager. So get the information through this information to undergo the additional next process. Okay. Likewise, they have given an error handler as well as the symbol table manager. This is the architecture of a compiler or maybe the phases of a compiler. Likewise, we are saying that. So next, first we move on to the so lexical analyzer. So what's the job of the lexical analyzer means? So lexical analyzer is also known as the scanner. Okay. So first you should read the what is given an input as a stream of characters. Likewise, so you have to read the source code. Okay. Source code. So even at the time you have to read only one character at a time. Okay. Lexical analyzer to read a source code one character at a time and produce a output as a stream of tokens. Okay, so in the token, so the lexical analyzer have to get the source code and translate it into the stream of tokens. So that's a process so taken in the lexical analyzer. Okay, so the token produced by the scanner serves as an input. So the token, the stream of tokens produced by the scanner serves as input to the next phase, that is the process. Okay, the lexical analyzer job is to translate the finally, the lexical analyzer job is to translate the source program into a form more conducive to recognized by the parser. Okay, likewise, it's a job of the lexical analyzer. Okay, see here shows the roughly they can show the compiler structure. Okay, so first one is the lexical analyzer, then syntax analysis, and then type checking, intermediate code generation, then optimization and target code generation. Okay, so lexical analyzer is a task to generate a token sequence. Syntax analysis to generate a structure tree or the syntax tree. Likewise, you have to generate this syntax analysis. So then, so type checking. Type checking is nothing but a semantic analysis. So what's the job of the type checking means? So elaborate we are discussing the later. Okay, so it's a attributed syntax tree. Okay, so this is a syntax analysis tree. We have to produce only this parse tree. The semantic analysis tree, they have additional information about the same parse tree. So that's information is stored in the semantic analysis. Next to move on to the intermediate code generation. In the intermediate code generation, you have to generate the intermediate code sequences. Okay, so next one is optimization. So optimization is nothing but what to reduce the source lines of code. To reduce the source lines of codes, we have used the optimization techniques. The last one is a target code generation. Okay, so we have to spend a significant amount of time on more or less we have to spend significant amount of time but to spend on only on the lexical and syntax analysis compared to the other phases. Then likewise we have to given the compiler structure. Okay. So next, what's mean by tokens? Okay, so tokens nothing but a stream of characters. Okay, so token nothing but a stream of characters that identifies tokens from the lexemes. You have to given a lexeme. From the lexeme, you have to identify the tokens. This type of tokens, sir, is the output of a lexical analyzer. So token nothing but from the lexeme you have to identify the tokens. Okay, identify tokens nothing but is a stream of characters. So likewise you have to given the likewise you have to representation as a token. Okay, so tokens are used to represent so low level program units such as identifiers such as some value and x. Numerical literal such as 1, 2, 3, 1.35, C 0.6. So likewise I have given the numerical literals. Then operators such as plus, star, arithmetic operations, each and every arithmetic operator is under the category of the operators. Next one is a keywords. Keywords nothing but if, else, return. Likewise we are given as a token as a keywords. So many other language symbols. Then one of the important one is the what eliminating commands and redundant white spaces. If in the source code they have a commands are redundant white space means so if we have to generate the token stream, those things we have to eliminate in the stream of characters. Okay, so that is a token. Okay. So more or less, this token space is nothing. Token space is nothing but a sequence of space, tag, new line, or carriage written, or form feed characters, etc. These are all the white space. These are all the white space. Okay. So these white spaces. So when you are generating a token, so these things are eliminated. Okay. So that is a white space. Next one. So what is meant by lexeme? Lexeme is nothing but a sequence of non-white space character delimited by white space or special characters. For example, operators like plus, minus, star, likewise you have to given. Okay, so that is termed as a lexeme. Then for the following some more lexemes. So examples of lexemes, that is a reserve words, keywords, identifier, etc. So these are all the lexemes. Okay, you see each command is usually a single lexeme, pre-processor directives. These are all the examples of lexeme. Okay. Then, what are the classes of tokens? There are many ways we could represent the tokens of a programming language. One of the possible ways to use a token means is a tuple of the form. Okay, so tuple of the form. Okay, they have given a token class. Then additionally we have given a value. So likewise we given a so classes of a token. Okay, so we have given a token class. Then within that we have to given a value also. For example, here you have taken a token class as an identifier. Okay, so what are all the values for the identifier means as a sum and you have given an identifier class name as a sum and value may be represented as a here we show that identifier is a class, token class, then value is a sum. Okay, likewise we are given a classes of a token and then identifier comma value respectively. So these are all the classes of a token. So classes of a token is nothing but so how to represent the token of a classes means it's a tuple form. Okay, that is nothing but a token class. Within that we have to given a value. Likewise we have to represent it as a classes of a token. Okay. Then, so another one token classes is a numeric literal. Okay, the same way. So the past we have see that so like that we have to same representation we have to given a here the token class is a numeric literal. So you have to given a value as a numeric literal means so 1 2 3 1.356 E06. Likewise I have given a value. So you have to again represent it. So numeric literal comma 1 2 3 and then numeric literal comma 1.35 E06. So likewise even a classes of a token. Okay, so apart from that they have applies for the operators also. For example, operators is a operator classes are real low. Then here we are given at the greater equal to. Okay, and then add operator. Then add operator this is a plus or minus. Likewise are given. These are the classes of a token. Okay, then how to represent a token in the struct or in class format in C++ languages. Okay, so here we are given as even though token is always a enumerated data type. Okay, so that we are given here we are given a enum the token classes. So within the they have a values. There is a identifier and number list. These are all the token classes. We are given identifier, number, literal. Okay, these are the token classes. In that we are given a token class as a token class. The string is a token value. We are given a token classes means we are given a token class and then token value. So token class is a data type as a token classes. Then token value may be a string. So likewise we have to represent a token in the struct or maybe classes program. So here like this we have to represent it. Okay. Then additional they have given some more token classes. Okay. So for the following they are given one expression x is equal to 2 plus f of 3. Then here identifier is a x. Then assignment operator is equal to number literal equal to 2. Okay. Add operator is a plus. Identifier is a f. And then so parent. Okay. L parent is a left parenthesis open parenthesis number literal equal to 3, then right parenthesis is there, so right parenthesis semicolon is a semicolon. So this is the formation of a representation of a stream of characters or stream of tokens. Okay, so this is the so token representation. From the lexical analyzer we have to get the output as a stream of tokens. Okay. Then here shows the another one example. If x of less than y min of x. So this source code passes into the scanner. Then from the scanner we have to produce the output as a stream of tokens. So as you all know, so semicolon is a semicolon, identifier x, then left parenthesis, then if token as if. Okay, likewise you have to represent it as a token streams. So next to move on to the syntax analysis. This is a second phase of a compiler. Okay, so what's the job of a syntax analyzer means? So take the input as a stream of tokens from that is produced by the lexical analyzer, and the frame that you have to build a parse tree or syntax tree. Okay, so syntax analyzer also known as a parser. Okay, so get the input as a stream of tokens from the lexical analyzer and then build a parse tree or syntax tree. That's the job of a syntax analyzer. Okay, so here when we have to build a parser, we have to go through the we have to follow the some rules of languages. Okay, so from the rules of languages you have to construct a parse tree. Okay, that's a syntax analysis. Here shows the one more example about the parse tree. If you are taking a if statement, okay, so if statement means to categorize it. We have to generate a parse tree. There is a if, then if is a left parenthesis, right parenthesis. In between left and right parenthesis, we have the expressions. The next one is a statement. Okay, so if the expressions may be identifier, reloop, or number literal. Okay, so x is equal to 10. So likewise, this is statements assigning. Okay, so variable equal to expression, then identify number literal y equal to 23. So likewise, you have to represent a if statement. For the if statement, you have to generate a parse tree. Okay, so next, what are all the parsing techniques? Okay, so before you have to create a parse tree, okay, so you have to undergo any one of the parsing techniques. There are two types of parsing techniques. One is a top-down parsing, another one is a bottom-up parsing. Okay, before move on to the parse tree, so there are two types of parsing techniques. We have to move on to any one parsing techniques. Okay, that's a top-down parsing. Another one is a bottom-up parsing. So name itself top-down parsing is we have to construct a parse tree from the root and proceed towards the leaves. That is a top-down parsing. If it is a bottom-up parsing means we have to construct the parse tree, starts at the leaves and proceed towards the root. Okay, that is the bottom-up parsing. What are the examples under the top-down parsing means? It's a recursive, predictive parsing, non-recursive, predictive parsing. Okay, like these are the examples of a top-down parsing. Next one is a bottom-up parsing means it's operator precedence parsing, and then LR parsing. LR parsing means it's a shift reduce parsing, LR parsing, SLR, LALR. Likewise, you have to examples of the bottom-up parsing. Okay, so even a top-down parsing can be easily constructed by hand itself. Okay, for bottom-up parsing, they have a software tools also available. Okay, so efficient bottom-up parsings are created with the help of some software tools only. Okay, so bottom-up parsing is also known as a shift reduce parsing also. Okay, so bottom-up parsing is also known as shift reduce parsing. Likewise, we are discussing about the top-down parsing and then bottom-up parsing. Next, then what's syntax syntax analysis. Okay, then again the syntax of a language is defined by using a context-free grammar. Okay, so each and every pass tree you have to construct. Before you have to construct a pass tree, you have to follow the rules and regulations. So what's the rules? How to construct a syntax of a language means it's defined by using a context-free grammar. The context-free grammar uses a BNF rules to describe the syntax. So you have to given like this: if statement, if condition statement, else statement. So these are all the BNF rule. Okay, so through the BNF rule to describe the context-free grammar. The context-free grammar is taken as a syntax of a syntax analysis language. Okay. Next, so syntax of a language is specified by a context-free grammar. The rules in a context-free grammars are mostly recursive. A syntax analyzer checks whether a given program satisfies the rules implied by a CFG or not. If it satisfies, the syntax analyzer creates a pass tree for the given program. Okay, so here we use, for example, we have given some examples. We use a backness in our form to specify context-free grammar. For example, assignment statement means this is how to represent the identifier equal to expression. If it is an expression means if expression, so the identifier is just an expression. Number is also an expression. Then expression plus expression gives a expression. Likewise, we have to define we have to follow the BNF rule. Okay, so through the BNF rule to construct a syntax of a language. Okay. Next, syntax analyzer versus lexical analyzer. So, what's the difference between syntax analyzer versus lexical analyzer means? So, both of them they have a similar things, but the lexical analyzer deals with the simple non-recursive constructs of the language. If it is a syntax analyzer deals with the recursive constructs of the language. Okay, so these are all the small difference between the lexical analyzer and then syntax analyzer. The lexical analyzer simplifies the job of the syntax analyzer. Okay, so from the lexical analyzer output is the input to the syntax analyzer. So syntax analyzer job is efficient and so similar thing with the help of the lexical analyzer. So lexical analyzer simplifies the job of the lexical syntax analyzer. The lexical analyzer recognizes the smallest meaningful units in the source program. Okay, the syntax analyzer works on the smallest meaningful units in the source program to recognize meaningful structures in our programming languages. Okay. So semantic analyzer, next to move on to the semantic analyzer. So from this syntax analyzer, this third phase of a semantic analyzer. Okay, the third phase of a compiler is a semantic analyzer. So from the pass tree, you have to get the from the syntax analyzer, you get the output as a syntax pass tree. From the pass tree, you have to generate a semantic analyzer. Okay, semantic analysis gets the input of the pass tree or produced by the syntax analyzer. Okay, so in these phases, you have to check the source program for semantic errors and then collects the type information for the code generation. Okay, just we have to find out the semantic errors, okay, and collect the information for the next phase of a code generation. Here, so major thing is performing the semantic analyzer means it's a type checking. So type checking is an important part of a semantic analyzer. So semantic information cannot be represented by a context-free analysis. In the syntactic analysis, we have to bother about the context-free languages, context-free grammar. But in the semantic analyzer, we not bother about the context-free grammar. Okay, so likewise we have been discussed in the semantic analyzer. So semantic analyzer, so job. What's the job of the semantic analyzer is to attach some additional meaning to the structure produced by the parser. So already from the syntax analyzer, we have to produce a pass tree. From that pass tree, we have to give some more additional information produced by the semantic analyzer, as well as the type checking, and then that information is carried out in the semantic analyzer. We have to given some activities of the semantic analyzer. Ensuring an identifier is identified before being used in a statement or expression. Enforcing the scope rules of the language. Performing type check is one of the important Role of a semantic analyzer is a performing type checking, and the last one is a producing intermediate code. Likewise, this is the job of a semantic analyzer. Okay, then as well as static semantics. What is mean by static semantics means? So static semantics can be determined by the compiler so prior to execution, so including what are the static semantics means, so declaration and type checking. So these are all the activities included in the static semantics. Okay, next to move on to this, what's mean by attributes? So name itself you all know about. So what's mean by attribute? So attributes nothing but that is an extra piece of information computed by the semantic analyzer. This includes maybe the type of variables, constants, operators, etc. Likewise, you have to give the information about the attributes. So you have to, in the semantic analyzer, in the syntax analyzer, you have to produce a syntax tree. Okay, the semantic analyzer, you have to produce an annotated syntax tree. Likewise, you have to generated in the semantic analyzer. That's a annotated syntax tree. This is also a syntax tree that has been decorated with some attributes. The attributes nothing but some extra information about the identifiers or constants or operators. Likewise are given. That is the annotated syntax tree. There are two types of attributes is there. Then inherited attributes and the next one is synthesized attributes. What's meant by inherited attributes means? So inherited attributes come down the syntax tree from parent or sibling nodes. Synthesized attributes come up the syntax tree from child nodes. So this is the two example. This is the two attributes of the attributes. Okay, semantic analysis attributes. Okay, same inherited attributes, and the next one is synthesized attributes. Okay, then you have to give one more examples of a semantic analysis, that is an annotated syntax tree. So we given a of subscript operating n dx equal to x plus 3. So for this example, we have to generate an annotated syntax tree. So here the this is the left parenthesis, left hand side, this is the right hand side. So in between we have a assignment operator. So we are taking a root node as assignment operator. That's is equal to, that's the assignment expression. Okay, so left hand side and right hand side. Left hand side is a plus operator. Okay, then add operator, then that's a left is a identifier x and then right is a number 3. So likewise this left hand side they have a subscript operator. Okay, subscript, that's a bracket, the subscript expression. So in that left side we have given a and then right side we are given a ntx. So likewise, you have to generate the annotated syntax tree from the semantic analysis. Then even though the semantic analysis, they have already generated an annotated parse tree, then type checking. So likewise, the important roles categorized in the semantic analysis. There's another one possible in the semantic analysis means they have to categorize, they have to include so optimization techniques also. They have a small optimization techniques to present in the semantic analysis. For example, they are given a so constant folding optimization is also carries in the semantic analysis. For example, x is equal to 2 plus 4, you have to optimize it into x is equal to 6. So likewise, this small type of optimization carries in the semantic analysis. For example, you have to give a temp equal to 5, then a of index equal to temp. Okay, so you have to give a two statement. Okay, so these two statements can be optimized to the a of index equal to 5. So this type of optimization carries in the semantic analysis also. Okay, then next one is phase is the intermediate code generation. Okay, so name itself, you have to generate a or intermediate code generation. Okay, compiler may produce an explicit intermediate codes representing the source code. So from the parse tree, you have to generate a intermediate code generation. Okay, so intermediate code is nothing but it's a machine code. So machine code is, it is a machine independent code or maybe object code. Likewise, you have to name it. Okay, if it is a machine independent code or machine code or object code or intermediate code, likewise you have to discuss in the intermediate code generation. Okay, so closely related to the machine code. Here we look new value equal to old value star fact plus 1. So this is a new values are identifier 1. So old value is a next identifier 2. Then fact is a identifier 3 plus 1. Okay, for this source code, we have to generate an intermediate code. Okay, so we have to given a ID2 plus ID3. Okay, we have to both multiplication operator. Okay, so you have to given a multi, then ID come to ID3 comma. Okay, these two values store it, you have to multiply it and then store it into the temporary value, that's a temp1. Okay, then temp1 we have to add it with the 1. Okay, so temp1 is added, so that we have to given a here add. Okay, temp1 comma star1. So these two values store it into the add it and store it into the temp2. Then temp2, the right hand side operation is storing into the now in the temp2, then temp2, so move it into the id1. So that we have to give a move. Okay, move temp2 to comma id1. So likewise we have to generate the intermediate code generation. Okay, next one is a code optimizer. Okay, so the code optimizer is nothing but you have to reduce the code or optimize the code generated by the intermediate code generation. In the previous phases is the intermediate code generator. From the intermediate code generator, so you have to optimize the code. Okay, that is the role of the optimizer in terms of time and space. Okay, so you have to optimize the code in terms of time and space is the role of the code optimizer. Okay, so you have to give a multi comma id2 comma id3 comma temp1, then temp1 added with the hash1. So let's move it into the directly move it into the id1. In the previous case, we have to give a, so you have to add it and then store it into the temp2, and then temp2 is add again store it into the id1. See, here the three instructions are given. In the code optimizer, in the two instructions, within 2 lines of code, you have to generate the code intermediate code generation. This is the code optimizer. Okay, so role of the code optimizer. Then an intermediate code, so produces object code. Okay, likewise you have to generate the object code. Okay. Next one is so what's mean by, finally we have to discuss about what's mean by tokens, what's mean by parse tree, then what's mean by symbol table, what's mean literal table, then last one is the intermediate code, and then we have to finally you have to discuss about the structure of a compiler. Okay. So tokens. So I already know about the tokens. Okay, tokens nothing but the stream of characters. Okay, so it's the output of a lexical analyzer. So often a token is enumerated type. Okay, so may include other information such as the spelling of identifier, value of console. Likewise, we are discussing in the tokens. Okay, then next one is a parse tree. So parse tree nothing but is the output of a syntax tree. Then is again input to the semantic analyzer. The semantic analyzer is a producer annotator syntax tree. Likewise, we are discussing the past. Okay, so each node here in the syntax analyzer tree, each node is a record whose fields contain information about the syntactic constructs which the node represents. Here, how to represent the nodes in various ways means a C structure, a Pascal or ADA variant record, then a C++ Java class. Likewise, you have to represent the nodes. Okay, these are all the various ways to represent the nodes. Then next one is a symbol table. So already you know about the symbol table. You have to give a additional, you have to store or keep information about the each and every phases, about the identifiers. Okay, so keep information about identifiers declared in the program. So how to how to get the information means, so this, here if you have to given a, so hash table or three structures may be used. Okay, so from there you have to get the information. Several tables here you have to maintain in the list or stack. Likewise, you have to maintain in the symbol table. Okay, the last one is a literal table. Literal table, you have to store the constant strings used in the program. Data in literal table applies global to a program. Okay, if a data, if any of the data is in the literal table means is applicable to the global to a program. Okay, so each and every phases, each and every, so apart from that they have external use, so it's a applicable one in the literal table. Okay, so deletion is not necessary in the literal table. Okay, then what's mean by intermediate code? Intermediate code, how to keep means to be kept in an array or temporary field or linked list. Likewise, are represented in the intermediate code. So representation include P code or 3 address code. Likewise, are represented as an intermediate code. Okay. So last one, sir. So structure of a compiler. Okay. So you have to given a, here you have to give an input, that is a position equal to initial plus rate into 60. So this is move on to the lexical analyzer. They have to give us strong stream of tokens, that is identify 1, identify 2 plus identify 3, then into 60. So that's the input, that's output is input to the parser. So from the parser you have to generate the parse tree. Okay. So you have to given a cement operator. This is the left hand side, this is the right hand side. So left hand side is id1, so plus id2 star id3 into 60. So this is input to the semantic analyzer. So from the semantic analyzer you have to generate the annotated parse tree. Okay, so you have to abstract parse tree and annotated parse tree like this are given. Okay, here I have to given a, so one more important role is the type checking. Here 60 we are given, 60 maybe is integer to real, maybe so for semantic analyzer for type checking you have to given a, so integer to real to 60 like this are given. So from that you have to generate the intermediate code generation. Okay, so intermediate code generation you have need a temporary variables. So first one integer to real of 60, so move it into the temp1, then id3 into temp1, so multiply it and then store it into the temp2, then id2 plus temp2, so add it on and then store it into the temp3, and finally temp3 is stored into the id1. Likewise generated with the intermediate code generation. The last one is the code optimizer. In the code optimizer, so you have to reduce the lines of code. So how to reduce the lines? Here 4 lines of code. Here we have to given up only 2 lines of code. That is id3 into 16.0. That's multiply it and then store it into the temp1. Then id2 plus temp1 is added and then store it into the id1. Okay, likewise I have given the code optimizer. The last one is a code generation. From the code generation, we have to generate the target machine code. Okay, so target machine code is nothing but is assembly code or object code. Likewise you have to name it. Okay, so here we are using a registers. Okay, then we have to move f id3 comma r2. So then we have to multiply it 60.0 comma r2, then move f id2 comma r1, then add f r2 comma r1, then move f, the final answer store it in the r1, then r1 store it into the move to the id1. So this is a structure of a compiler. So each and every phases you can communicate with the error handler as well as the symbol table. Here shows the symbol table. Okay, so what are all the identifiers, what are the type of identifier, so value of identifier, type of identifier, and type value of constant. Likewise store it into the symbol table, that is a position, initial and rate, etc, etc. Likewise you have to give the information, store the information in the symbol table. And the last one is the compiler writing tools. So what are the compiler writing tools? Here we have discussed only one, that is a compiler generators or compilers. So I have to give an example, scanners and parser generators, example York and Lex. Okay, thank you students.